So the total area under the normal distribution is 100%. The area under the normal curve that lies within 1 standard deviation, and what that means is positive 1 standard deviation and negative 1 standard deviation. That area between -1 and +1 is approximately 68% of the total area of that. So most of the area is between plus and minus 1 standard deviation. Plus and minus 2 standard deviations from the mean will include approximately 95% of the total area of that particular distribution. And then plus and minus 3 standard deviations of the mean is approximately 99.7, or almost all of the 100% of the total area of the Z distribution. And then there's a very small percentage out to the right tail and a very small percentage out to the left tail. Now there is a chart in your book, and it looks like this. So we can see that we have some decimal places out here. So we're just going to say about. So we're assuming that this is about the right amount. And in different textbooks, you'll see different values, but every textbook is going to be 68, 95, and 99.7. Those are pretty standard across the industry. So like I say, plus 1 standard deviation and minus 1 standard deviation includes 68% of that total area. So if I asked you a question like, what is the area under the normal curve between the mean and 1 standard deviation, your answer would be 34.13%, or about 34%. And if I asked you what the total area of the distribution that lies between the mean and 2 standard deviations from the mean, or plus 2 standard deviations, so I'm talking about this area right here, so I would just add 34.13 and 13.59 together to get that answer. Now if I asked you a question like, what is the total area between -2 standard deviations and -1 standard deviation, so I'd be talking about the area under the normal curve in this area, so that answer would be 13.59. So as you can see, as the frequency dips off, as the standard deviations move farther away from the mean, our percentages start to shrink. But always remember that these numbers are constant. No matter what values of X that you get for some test or some instrument, if you plug them into a standardized curve and you standardize your instrument, they're always going to have these percentages, always. Since each normally distributed variable has its own mean and standard deviation, like I say, it doesn't matter, the instrument or the test or something like that, it's going to have its own values, but it's going to fit into that curve perfectly. The standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. So we already kind of went over that. Now this is the actual formula, which is pretty easy. So if I have a value of X, I will subtract the population mean from that and divide it by the population standard deviation. And that will give me a standardized score, and I can plug it into that, I can plug it right into that normal distribution on that distribution of Z, and I will know exactly where that score falls. Then I will know how many people, if we're talking about people, score above that, how many people score below that. So it's a very good statistic that we use in research and a lot of other things. Area under the standard normal curve to the left of any Z value. So like I say, Z is that standardized value. So we can look up Z values in the table, and the tables are in the back of your book. And I gave you a video. It's a really good video on how to use that table. So give that video a look, and that will give you, a really good description on how to read those tables. For your quiz and for the exam, I'm not going to make you look those tables up, but it is a good idea to be able to use those if you go on to more advanced statistics classes. So as you can see, to the left of the mean, I have a negative z-value, and to the right of the mean, I have a positive z-value. So to the right of any z-value, I'm going to have, like I say, a positive, and to the left, I'm going to have a negative. So between two z-values, that's kind of what you're going to be doing on the quiz in a very simplistic way. Now there's formulas for knowing exactly what the area is because we already know what the percentages are for each area. However, as you can see, this curve, it dips down. So if I have an area between -1 and -2, as you can see, if I just cut that in half, the half closest to the tail will have fewer frequencies than the area to the right. So there are formulas for that, and we can get very precise. However, like I say, I just want you to have a general idea of how this works for this particular class. So there's some examples in section 6.1, page 309 of your textbook. And now what we're getting into is the theoretical concepts, and we're going to move into hypothesis testing. So understanding these areas is pretty important. So from the table, the area is 0.9817 or 98.17%. So 98.17% of the area is to the left. So everything to the left of this particular z-value, which is 2.09. So think of these z-values as standard deviations. So it's 2.09 standard deviations to the right of the mean. That makes up 98.17% of the total area to the left. So there's only like 1.8 something percent to the right here. Very small percentage over here. Very little area. So 98.17. So about 98% of the total area of the z distribution lies left of this particular z value. And you can find that by looking up the tables in the back of the book. Or if you had just you can add 50% and then 68.13 and then another 13%. You can kind of get close if you add all those areas up between those standard deviations. And that's a pretty good, easy rule of thumb to get you pretty close. But if you want to get really precise, and when you would get really precise if you were doing percentiles and things like that, we'll talk about that in a little bit. But it's pretty important that we understand these areas. So there's more examples in the book on that stuff. And the same thing, if we have a z value, a negative 1.14, or think of that as a minus 1.14 standard deviations from the mean, and then I've looked that particular z-score up, it's actually going to give me an area to the left, but then all I have to do is subtract that area from the left from 100%, and that will give me the area to the right. So to find the area in the table, you would just use like I say, you would use the area, and you subtract that area from from 100%. So it looks like that we're getting 87.29% of the area to the right of z. So that would be this area here. So like I say, the table is going to give you the area to the left. You would just subtract that area from 100% to get the actual area to the right.